visible. It's quite basic, but these are the little things that could just make your design experience to be very frustrating. At the same time, it could also make it very interesting. All right, so we'll click on this. And now, how do I know the depth of which I want to split? So this one, you could just use your design sense. Let's switch views. You can see what's happening inside, right? If you should look at that, if you should examine this, let me quickly turn off this body. If you should examine this, let me even go back to normal view. You could see that when we talked about external interaction with the user, this is where you also have to liaise with your electrical designer, because he will be the one to tell you what is what, how it will work, right? So from my own investigation, this will be a point. This is your port rather. So this is where you're going to have your external is a battery port. So you're going to have your battery probably wired around something, and then the head now where you have the port itself would be clipped into this other section. So all I'm saying with all of that is that this one, you need to have an access to this from the external casing. From outside the casing, you have to have access to this. You have to have access to this. You need to have access to this one too. And let's see if there's any other one. And this one as well, right? The heat sink, you don't need to put your hand on it, right? The transformer doesn't concern us at this moment for this in the context of what we are discussing, right? So what that simply means is that I could cut off my enclosure, I'll turn it back on. Remember I said my plane is my knife, right? Turning this one back to wireframe. It means I could cut this all the way here, but I can't exceed. I will probably want to stay away from this region, right? I'll probably want to stay away from, I'm showing us like some thought process now. I probably want to stay away from this region where we have, that's cutting, making this the split points of our case to be this point. Because it will bring in a lot of complexity, even when you're trying to print. That's one. And secondly, when you're probably, even during the design process. So I have, there's no much complex, component on the board that is restricting my, maybe how we could cut it. So all I can simply do, I could just say, let this guy be 25. It's moving upward, sign convention. So I'll just move this to minus 25, right? So in case someone will ask me, how did I come about that? I believe that's clear how I just, had the little thoughts there and then decided, okay, let's use here and see how it goes, right? I'll click on OK. Now this is where our split point is. Probably want to return this to a more better view. And then immediately remember I said two things. You have the plane, then you have the plane for cutting, and then the command, which is the split. So also to be on the like a good practice, like I always mentioned. So this will be given names. This one will be called base plane. It was the plane we use in making the base sketch, because things could get a little messy when you start having many things on your timeline. So this one I will call split. Understand? So once you see it, you know what it's for. Split plane. Are we together? So I'll just go over, pick on my split command. Remember, so we need a plane. So I'll pick this body as what? Remember, look at my dialog box. It says body to split. So I selected the body. Next thing is asking me what? Splitting to. That's this guy I was talking about, the plane. So I'll select this and go over and select the plane. You can see what's happening there. So that's exactly how it's going to cut out the enclosure. So click on OK. Now we notice on our browser we have body 1, body 2, and body 3. So basically saying we have 2 bodies now. So to also be on the safe side, what do? I simply call this bottom enclosure. Enter. This other one, what do you do? So I believe these are very are things we could relate with. I'll just say top enclosure, right? Next thing, we can now say, okay, turn off top enclosure so we can see what's happening inside. Hope we are getting it now. So of course, at this point, we don't need the plane no more. So off the plane, right? And this is what we have so far. I believe it's coming out. What we saw on the screen is coming out, right? It's coming out. So the next thing we need to do, since there are not much thing on this board, like you get what I mean, like the board is not very complex for learning purposes. So we just need to erect a standpoint, because someone might have been asking, if you're very observant, are we going to, let me turn on this guy. Are we going to suspend the PCB on the air? Of course, it doesn't make any sense. I don't know how you're going to do that. Maybe, I don't know, some form of maybe magnetic effect you might use to suspend the PCB on a plastic, you understand? So what do? It means we need certain things to be like holders. They will hold the PCB. And so this is where you as a designer also, who is handling this part, you need to stand your ground. So for instance, maybe you want to go about using a bus, right? This is what a bus simply is. I'll just show you that. What it looks like. Okay, we have a web here. I'll have to switch to plastic, and yeah, so that's a bus. Please, can we look at I just highlighted and kept my mouse so we could see. Can you see what's happening on the other one with the blue? The left part of my screen. You could see something going into another, right? So first of all, this will provide you a channel to pass maybe your screws or bolt through, right? The right word will be screw rather. You'll pass your screw through. It will also be another provision for you to use it as a holder for something. You can also use it for reinforcement, right? That's when you now apply the bus and you now go ahead to apply the rib. So I will create this bus manually, but we'll come back here, and then, because I believe you have been given the Fusion license, the educational license, which gives you leverage to a lot of things that are not even available to other users, you understand, commercial users, except they pay for them. So you will on your own, that's when you're now working on your own, not use my method. You're not going to create the bus manually. I will employ you to create the bus using this word commands. It's called Fusion words extensions. They are remember, I switched from solid to plastic. So this is where, in case you start looking for how I got here, right? This is it. But I will create it manually, and then probably on your own you will create using the automated feature. So how do we do that? First thing I need to do is to turn off the PCB for now. Just for a moment, I'll turn it back on so I could really see my inside the bottom. To turn off that, and then I click on PCB off. So I'll turn to see, click on my home so I could see the enclosure. So you see this surface. This was the surface we did not want to have direct contact with the PCB. That's why we pushed that plane down. So now we just come here. Is it that you run away down to your top, the top left of your screen to select Create Sketch, or you simply just right click here, right? As long as you're touching that and you click on Create Sketch. Another trick I even do most times is I can just come here, just a quick way, but sometimes it could be annoying to run around the screen. So you could just click, for instance, L. You know that L is like a line command, right? So clicking L and clicking that plane is like saying I want to draw a line. So automatically it has taken me to the sketch mode. Then I can decide to use escape to deactivate the line command. So either way you find, going to the top left to just create a sketch. That's the important thing. So you created a sketch in this part, right? But there's no sketch yet. It's just an entity called sketch, which is sketch 3 if you look at my screen now. But there is no actual, there is no data inside. There's no line, there's no geometry, right? So what do? This is where I need my PCB once more. I bring back the PCB. And like I was saying, standing your ground. These holes are quite important. And what if maybe you're trying to use this method and probably there are no holes on your PCB? Of course, you need to now get back to the electrical guy and be like, oh, what's the plan? Like, we are not having any points where we could grip the PCB to the enclosure. If there are other plans, then that's fine. But if there's none, he has to now include this in his in his design to help you. You understand? Remember when we said part of one of the requirements, we say cost effective, right? There are many ways you might want to add this to this, but which one would be easier? Maybe when printing or manufacturing, it's just very easy to get it out. You understand? So, okay, I'll just do a projection. My ask, why projecting? I need to know where the circles are, but not on the PCB. I need to know them on this current sketch. Can you see now there's nothing on this sketch? That's where we are currently drawing, but it's there on the PCB. So what I'm doing by projecting is more like saying, just like a projector that you use. So you're taking that geometry from somewhere, maybe that's existing on probably another product or whatever it is, and you're sending that, you're replicating that exact, more like signature now on the current space. And what will be our current space? That's the bottom of this enclosure. I call this signature because definitely that's how it works. If there are changes, there are certain changes that will be done, even when you don't have an error in the design, you will still see that your black line, which maybe probably showed, or purple line, which showed that it was projected, or the black line, which shows that it is fully constrained, they could change to maybe a gray color. So it's telling you that something has happened. Yes, it's still the same circle, but there's been a change in the identity, right? Let me not go too deep in that, but just take note that you need to do your projection. So you just come over to this point, you click on project, select this circle, this circle, this circle, and this circle, right? If you click on OK, you can turn off the PCB now. We don't need it again. But what do you notice first of all? These are asymmetric. They are not symmetrical, if you notice, right? And this is also from the way the PCB is designed. So if it could be changed, like, the PCB personnel, please help me correct this on your PCB. And he says, okay, okay, no problem. He does it. That's fine. But if you cannot, and there's still a way you could go around, still getting the job done, that's fine. But if it's probably there is no way around it, then that means the electrical personnel has to probably incorporate it in his own design. But what I'm trying to say, normally this projection we just done here, we would have created just one and then do a mirror to get it on all the sides. But because they are symmetrical, we cannot do mirror because we'll not be able to get it right. The mirror works as, symmetric, is a symmetric kind of feature. So on that note, what do I simply do? I will just come over to say, okay, no problem. I'll pick up my circle and just use these things we projected as snap points. In fact, at this point in time, you could just say, okay, click on your circle, click on let me zoom a little bit so we can see. Click on that, move out, just click and drop for now. Click and drop. I'll zoom into this other section. Click and drop. Later I'm done with this step, I will pause and wait if there's any question. So you could just start keeping your question, right? So next thing, there's a parameter we created. I'm very sure maybe we've forgotten, but there's a parameter we created for that, which we call the bus diameter. Have we seen bus diameter? So what do? I'll come over now, constrain. Now let me just quickly do this. There's something called constraint when you're working. This is not just a fusion thing now. This is like, let's say, CAD as a whole. And they are basically broken down into two. If you know this, it could be a refresher. If you don't, you take note of it. It's quite important. The first one is called what? Your geometric constraint. And the next is called your dimensional constraint. So see all those things I will say 5, 6, just put here, draw. That is what? Dimension, right? Dimensional constraint, as simple as that. So when I pick up a line pick up this dimension 2, a shorter way, a shortcut is D. So if I click on D on my keyboard, it still pops up the same thing. And do this, I'm defining the size, the magnitude. So I've put a constraint, but a dimensional what? Constraint. So now instead of putting 14, I'll bring in the parameter called bus diameter and select enter. Now, the next one, I will still say, okay, let me click on this and do the same thing we have done. But that does not even make much sense since they are all the same. Let's just leverage another form of constraint, which is what geometric constraint now to get the same job done, which is even a better way to go about it since they are all what's going to be the same. So what do I do? Instead of going over to still pick line dimension 2 to dimension this, I come over to geometric. So why are they called geometric? They help you position and place what the things you're working on, maybe your sketch. You understand? Don't forget that in Fusion, the right term now to call everything what you're seeing on your screen now is what? A geometry. The sketch you are drawing will not be out of place to call it your geometry, even your 3D file, right? But maybe when you want to get more detailed, you can now say, okay, this one, sketch, this one, body. You understand? But in a more like encompassing term, you just call it geometry. So what you can basically do, you come over to see all these constraints. You have coincident, tangent, equal, parallel, and so on and so forth. They are so useful. All are useful. There is none of them that is what useless. You will see that when you're probably working on something and it's just a particular feature or constraint that can help you, achieve that. So in this case, since we said we want everything to be equal because they're actually equal. So what does that mean? I just come over to see if there's anything like such a constraint. So this is a constraint called equal. So I just click on equal. So once I click on the one I want to, that's the intended geometry, and then click on the reference, can you see they all update the same size? So I don't need to go and put dimension again. I'm just using what geometric constraint. So I have to bring that up because it's very, very important, very useful. Click this, click that. So they are all what tied to the mother. Who is the mother now? This will be the way you could actually do the control of, okay, I don't want it to be 12 again. Let's make it 13 and all of them will become 13. Are we together? So just before I proceed, I think I might pause for questions. Any questions? Feedback, please. Any questions?
Does anyone has questions, please? Sir, no one has questions. You can continue, sir.
All right. So the next thing we are going to do, since we now have the shape of what our enclosure should look like, sorry, the bus should look like. So I think I explained what the bus is and how it works. So what we simply do is just to add form to it. So you just click on extrude. You come over, you select, right? Now I would have said let's exclude this, but no, we actually want to do a threading of the bus. So we have to still include this inner part, right? So click on this part, click on this part. Same thing here, select. So once you've done that, you pull it up, right? Now the next thing we probably want to look at is where will it stop? We're talking about the extent now. Will it be all the way up, all the way to the end? So how do I get to know that? I'll call in the PCB again. So you see why the PCB is quite very important. In fact, it's like your lifeline now for most of the decisions you're going to make. So of course we can't have this. How would the bus go outside the PCB? It can't work. So it means it has to be under because it's even supporting. So it has to be what's under. But how do we know where to stop? So this is where we do what? We could do a section so we could see. So you can see what's happening right there, right? Now, like I said, if there's going to be an obstruction between this thing you're creating and a component under, that's where you and the PCB person, the electronics person, and we're having constant communication. This will not work. I cannot do this here because of this. He will not check if he is the one that will what control, remove that, or if you are the one that will compromise, there has to be a compromise on both, both parties. You understand? The important thing is that the product works at the end of the day. No one will go. You won't go to the market, maybe to pick up maybe a torchlight, and you're asking who manufactured the glass. Did he do it probably well? Was he having an issue with the person that designed the plastic when they were all those? That's no, you can't even see those information. All you're just seeing, this is a touch, it's fine, it's looking, it's strong, it's durable, it lasts longer. Those things you're seeing probably during the design stage, there has been some compromise on both parties, right? I just had to explain that. So the next thing we are going to do, like I said, to know the extent. So what I will do is I'll come over to my dialog box, put this in so we can see it properly. And then on my extent, can you see extrude extent, right? I will change this from distance to object. That's to object is the name of that the command we are about switching to. So once I do that, it will now allow me to select this object in question. So I'm moving to the PCB and select. This is what will happen. Can you see? Then now, why I love this command so much is that you still have that leverage of doing what? Offsetting, because of course we don't also want it to be directly on the what? The bottom. So I can now have what? Bring in my clearance again. Remember, FDM. Right? I will just use FDM as the gap. But there are cases maybe you want to use, because there are cases where you want to use some insulation. Like I'm pointing this out to you because when you're doing yours, you're supposed to bring in these different ideas and nuances into your own design. You understand? But we are showing you how it's done, and we're also telling you why you should do them and how, the consideration. So there are cases where you want to have insulation under. If you've noticed, if you've opened most of these components, you see that done most times before they put the screw on the top. There's an insulation under, more like maybe a rubber or plastic that will be used. If it's maybe a more mechanical device, you call it washers, like if there are machines and the rest. So, but for components like these, are mostly maybe rubber or plastic in nature, or maybe a composite material, something that does not, that won't also cause maybe short circuiting. You understand? So if you're going to have that under, that is where this one I have. I use mine now called clearance FDM. You won't use that. You're going to use something that will accommodate the clearance, what's it called now? The material you're going to use to do the insulation. So I hope that is gotten. So you don't come to ask me. It's not as if it's always going to be, 0.5 or no. You're designing for something, and all your actions should, if at least 80% is something that you can, defend, like there's a reason behind it. Are we together? So I'll just click on OK. Click on OK. So we've gotten that. I will turn back on this section, probably turn back off the charger. So this is what it looks like. And just before we continue doing any other thing, if you're looking at this properly, you could see that there could be an issue. Some form of stress or push could make this member to pull out, and it automatically means that that point will no longer be gripped. I don't know if you know most of these touches, those fake ones that used to get back then. That maybe if they just hit on the floor, something pulls out, maybe the wire is no longer staying where it's supposed to be, or the battery can no longer stay. So most of those things are because of how the casing was probably designed. You understand? So a little thing, something breaks off, and that's the end. It cannot go back in. You understand? So how you take care of most of these? The first one was the web, which I said you will go try this one. I've showed you. This is how it works. This is where it is on your plastic. You see product design extension. So this is it, right? So if you probably still want to know how it's used and you're having issues, so when you click on the command itself, for instance, let me click. You'll see something like learn more, right? I hope we're all seeing that. You click on that to take you to the web page that will give you a description of how to go about that. So I really do want you to use that on yours, right? We are doing ours manually. So now we'll go back to the crate and just do this one thing. This is the feature we use, the sketch we use in creating that boss. So right pricing, what do I quickly do? I'll call this what? Boss. So this sketch was using creating boss, I'll call it boss, right? So that sketch that was using creating the boss, I want to edit it and add something else to help me do something else. So what am I saying? Right click, edit. We are in. Now we are back to the sketch, right? So I will just incorporate, I want to use it as my reinforcement since I cannot, I don't want to put the rib now, right? I don't want to use the rib. I don't want to use other forms to do that reinforcement. So this is one way you can go about it, which is quite basic and quite easy. So you just, right, you can see what I'm doing there. It's a circle. I just picked a circle. Make sure they are on the same point. Just pick and drop, pick and drop. That's what I mean by that. Click on the center so it snaps before you pull your hand away. Snap the middle, pull out, right? Now you could now assign what the dimension to this, right? So to even be on the safe side, what can I do? I could say, let me project these edges. Are you seeing these edges? So I just click P on my keyboard. It will allow me to pick this point and this point. So notice what will happen now. I will go back to constraints and use tangential. So most of the things I'm doing for this case study are very intentional, please. I'll click on tangential, I come back, I click on the circle, and I click on that edge. You wouldn't have doubts as to the reason why it is fully constrained. Why? I have pinned it in the middle, and now I'm saying be tangential to this line. All the degrees of freedom are gone, and that is why it is looking that way, right? So do this, do that, do this, do that. Click here, right? This one will probably not give us what we are looking for. So we can also leverage, we'll delete that and use maybe geometric for this one. So D for dimension or equality rather, use an equal. Sorry, 1 minute, please. Let me put on my power. I think I have a low battery. Please, if you have a question, you could just coordinate it. So once I'm back, you could ask. Please confirm that my screen is visible. I had to open up the file again. So
Yes, sir. Your screen is visible, sir. You can continue.
all right, so let's just proceed. We had created the boss and we are talking about going back in the timeline and doing this, right? Okay, so probably we just have to take all of this again. Get this off. Yes, I'm just trying to correct, when it's switched off, some things kind of take a different turn. All right, so back to where what we are doing, we had to project this corner and this other one. Okay. Then we said, no, we had to equate all of this. Then we said we use a tangential command constraint to pull this back here. Right. Sorry, I think we have. All right. But this was the one that gave us an issue, which I said we should probably correct before everything went off. So we just let's see what's happening down here as well. And some of them have gone out. I'm just redoing the things we have earlier done, which seems to be have scattered. Probably did not save the last thing we did. I'm just getting it done immediately. Okay, so this was the only one I said for it to be tangential is now. Remember, I said it's not symmetrical. So don't, you might be wondering why is this one's going fine, but this other one seems too big. Look at its position, look at this position, look at this position, but for this one it's different. It's still tangential to the line, but it's bigger. Understand? So for it to be uniform, what do? We will not use that same constraint. Please, can you hear me, please? Can you hear me?
Yes, sir. We can hear you, sir.
All right. So just go ahead to can use the equality now for this particular one. Equate it to the model. Oh, that's good. So the next thing we are going to do, we just erect. Remember, we've already done the first extrude, which gave us the bus itself. This one. Yeah. So we just went back in time. That's the beauty of fusion. That timeline, playing with your timeline, right? Just went back in time to add something intentionally so you can see how it works, right? So we just come over and then say another extrude. You still leverage the same sketch, right? Same sketch. I just noticed something as well. If you're also observant, it seems this other one is also a little bigger. So let's click edit. Probably remove these constraints and also use an equality. You of course know where the why it's looking that way. Like I said, it's not symmetric. So say equal. So still equate this to this as well. Now, it will be weird having some of them, big and the rest small. It doesn't make any design sense. So click on this part. Click here. Click here. Now look at what I want to do. I want to select the sketch inside, but I'm obstructed. So you left click on your mouse and hold for a while. It gives you this dialog box, and you can use that to what? Do your selection. It can come in very handy. So I just had to show you. All right, so pull this all the way. Remember, I said it's reinforcement. So we won't take it too much. We'll basically say 2.5. Okay, sorry, 4 mm. Okay. Also do it a join command. Right? And then the next thing you could just probably do is now we want to drill that hole for the PCB itself, because basically from the looks of things, the only thing remaining to work on this bottom is just to put where you will have the external interaction with the port that we have on the PCB. So that means we are getting close to finalizing on the top bottom enclosure rather. So basically, what we could simply do, okay, just expecting. What we simply do is to go back to your whole command, pick up your whole command, then you just do a selection. Now I want to do a multiple selection, right? You see, it's not letting me because it's just trying to align to just one circle at a time. So how do I get this done? I could play a little trick here, right? Cancel this command, go over to the sketch. We know we don't really want to use it like as if we are using it to sketch something, but we just want to reference or use that center. That's what we use in creating these buses. Remember, I had a center. This is what I mean. First of all, do not forget you have to activate this. Right. Go back to the sketch. This is it now, right? So I could just turn it on. Right? Just turn it on. That's all I just wanted to be, just to have something. Now go back to that whole command. Now, if I do this, it's going to work. You can see what I'm doing now. Going to work. So you don't come and say, oh, Fusion does not do this. Most times, it just depends on how you're able to play the trick around the stuff, right? So, but what we are going to do now, if you notice, is going what? Down. Can you see? And that's because the sketch is under. So you're drilling a hole just as you do on your milling machine. The direction is coming, right? So it's just assuming that it is from here that you're pulling that hole down. Forget about the size, we'll correct that, but the direction first is not what? Correct, right? And a simple flip will not get it done. I'm just doing that to show you. Why? It is still going to be assuming that you're drilling from this point upwards. So it's still, either way, is not what we are trying to achieve. So what do? I'll cancel that command. The sketch is still visible. So I'll run up to this point and just create a sketch on it. And once it's there, all I need is just points. So I'll just do P for project, or you go over here to
Excuse
pick
me,
it up.
stuff.
Yes.
Sorry, we have 15 minutes left.
We have
15 minutes, 15 more minutes.
Okay, I think that will be enough to complete the bottom. And probably we'll just do the top and then get into something else by tomorrow. I believe we all know the reason why it's this way, so we just have to manage what we have, get the best out of what we've been able to do. Thank you for that feedback, Tolu. So simply, like I said, I'm creating a sketch now on the top, right here. So I will now project that hole. I still need the hole. You can see a red dot here. So if I go there, is bringing that dot that is on the floor to the top. In case you're asking how the projector works, I've been trying to hammer on that because it's really it's one of the basics that makes your life easier, right? Just move. Same thing, the same hole. Same thing, same hole. Take note, all of this process are because the holes are not symmetric. If they were symmetric, we'll create just one and we mirror and get done with it. So it's also good for you to know these different routes because anything can hit you at any time as long as it has to do with what's this design and all of that. So click on OK. You can see my sketch is on the top now and it's recorded here as well, sketch 3. So I can turn off boss, right? And turn this one, I could call it hole. It makes your work what's readable, understandable, and is a professional way to go about things, right? So I'll say HOLE, right? So that sketch is just basically to get me my hole. So I just come over, I can finish up my sketch now, go over to my hole, repeat the same thing we did before, same thing, same thing, same thing, and then come over to, it's going to be a simple hole, it's going to be a threaded one, fully threaded, yeah, okay. Fully threaded. Then for the thread type, you can use an asymmetric. So if I'm also you, at some point it's good to familiarize with all of this. These are standards and they directly impact your design. In fact, for instance, if you look at DIN, you see that it's obtainable in a certain kind of country. Maybe you're designing we have like, for instance, maybe Russia or some other places like that. There are certain standards they use, unlike maybe down here in maybe West Africa and so on and so forth. For instance, the ACME, these ones are used for lead screws, like those ones that you see on your 3D printers that help move. So they all have functions and specific specifications. So you can just get acquainted with most of them, right? So for our screw, we use the asymmetric, and then we get to our size. We select an M6. Okay. So I'm not just selecting M6. The reason I'm picking M6 because we had a hole in the PCB, right? This PCB, if you can still recall, look at them, I've even opened it so we can see what I'm saying. We had a hole on the PCB. So definitely I'm not drilling a hole that will be bigger than what we have there. That guy already on the PCB has already constrained what we can use, right? When we say the PCB is a constraint in this subject matter, it really is a constraint. So we just do this. I've selected my M6 designation. The class, we can just leave all of this here for now. Then you click one more thing is the depth, right? So what do? I would control the depth using, okay, It's grayed out because we said fully threaded. So what we need to do now, we'll do offset. See, turn that on for us properly. Okay, no, I'll still use that. So we just come over to this point and select the depth of that hole. So if you remember our boss, he had a height which was 12 millimeters. We still recall, boss had as a parameter had a height 12 mm, right? So there's no how our thread will even be will exceed where it is going to, dwell in. So we are looking at possibly a 10. And while doing this, do not forget that Fusion will still allow you to bring in the standard screws, which we'll probably do before we close today. We have, I think, 10 minutes or more. So while you're also selecting, it should be 10 millimeters deep, you have to also, you need to also confirm that that is even available in the market in the first place. You're not going to manufacture the screw. That is not part of the job description for what you're working on. You understand? I mean, the screw manufacturing, that is already a big project on its own, if you understand what I'm saying. So you have to confirm that these things you're using, they're actually obtainable. You could go to the market or maybe order them, and then you fix them up. So we're also going to see, how that works as we proceed. So click on OK, just to accept. So one more thing, notice this jagged, let's see how that goes. Yes, on this top. So we'll go back to that whole, do an edit, switch to a counter ball to have a more uniform, then we could sync our screw in as well. All right. So these depths now, of course, it also exists when you're selecting the screw, you find it out. So we'll go with 2. So you can see what's happening there, right? Doesn't mean the first one is not totally correct too, you understand? I'm just trying to show you what you could do. So this is how it comes out now. Right, we'll have this. So if you quickly run on your section, let's see how that goes. So this is it. I believe that's okay. It's something I can move on to the next thing. Right. Okay, I just have to correct that. I noticed a little error on it. Okay, so having done this is what we are basically kind of doing now. This is what we've been able to achieve. Remember, we talked about a little clearance here for maybe your insulation. We talked about putting your hole all the way from the top and so on and so forth. So the next thing we are going to move on to do is to simply project, from the PCB. So I'll turn off the section view. And so we need to now know where these ports are on the enclosure itself, right? So that we can make the opening for it as basic as that. There's not too much grammar to it. So it simply means I'll just come over to this point. Like I said, it's the beauty of Fusion. You click on the model geometry and use it as your sketch plane itself. Understand? It has consequences, but with the subject matter, what we are looking at, those consequences are not very grave. Like they are not, so much. You understand? Like it's something you could always find your way around. So that's why, I'm showing you how to, get it done using that method. So you just click on this point, you say right click, you create a new sketch. We can't see what's happening there. So we just come to your sketch palette, you come over, you see slides, you click on slides. Right, all that's understood. So you could actually see what's happening within this environment. Understand? So what are we basically trying to do? We want to map where this PCB. Let me remove this for now. I want to map where the PCB ports, the ports on the PCB mounted on the PCB will be on the wall itself, so we can have the opening. So what will help us do that is what? Projection. So come over to our projection, pick the project tool. So this is how you could go about it. You just select this point. I need this other one in here. So basically, I can turn off the enclosure just for a moment, right? So that I can see what's happening and turn it properly. So I pick this, I need the under as well. So I'll tilt back. I know there are a lot of components and they're all looking, lines, and there. So you just have to pay like close attention and select exactly what you require. So if you take this a little, you will see how many things we've selected so far. I don't need this one, so I will click on control and select it again. It's off, right? Sometimes mistake could happen. So click on this one as well, and then probably use this space. So I've gotten that one. I've been able to map that guy. We'll map the next one as our port, right? Second one, 1, 2, 3, 4. Take note, I'm not doing this. I'm not coming over because you can also use this, but this will cause a lot of complications when you're trying to use. Remember, if you notice this body on its own as a component has a lot of hole here, irregular, features and so on. So you don't want to start mapping things into your design that would make your sketch quite unstable. Just a little change and everything is, showing you errors. You understand? Why is it blinking? Okay. Don't need that. We don't need that. Need this. Okay, so we are good to go for this other part. So basically click on OK. Right? Turn off the PCB now. This is what you have been able to do. This is what you've been able to do. Now, this other line running across, what is it? So let's find out. You turn back on the PCB. Zoom in. You find out that's the line under the PCB, which is not actually what I want. So what will I do? I will just remove it. So it doesn't even mess up our design. But we actually need the one on the top. Turn back the PCB on. We need this other line where the PCB surface ends, right? So I'll just go back to do my projection again. I used P on the keyboard. That's a shortcut. So I will tilt a little bit so I could see what I'm selecting. I just come and select this edge. That's what I need. I click on OK. Turn the PCB back off. So you see the difference now, right? So I haven't gotten this. You now zoom in. This is where we talk about, having broken loops. You can see this. This will not allow us to be able to do our extrusion. So I'll quickly close this up. That's one. Keep on looking if you see another. So immediately you do that, what you notice is that you see this is now selectable, right? It's showing you come over to this side, it doesn't. So the same thing, you close it up. Because if you're wondering why it's not extruding, you've done everything, but it's just not picking. These are part of the places where the problem usually comes from. Okay, so I will now do an offset. Now, what's going to be my offset? Remember that we had a wall a shell, which it represents the thickness of our wall. So we use that same parameter because what we are creating will also be joined to the base. So we don't want to have that non-uniformity, you understand, on the walls itself, because that can also be a problem, right? So we'll click on this loop. Okay. Or rather still, you could, a shorter way, you could just bring in a rectangle, right? Just click from here, click and drop, right? Come over to this side, bring another rectangle in, click from this point, click and just drop anywhere. Since we want to be there, was specific, right? So what do we do now? We could say D for dimension, that's dimensional constraint. Now I pick it up. I'll now say from this point to this point, I'll call it what shell. Why am I calling it shell? That's the thickness of our wall. Take note of that. Right? Same thing with this one. From here to here, dimension, how many? I call it shell. Right? Same thing, shell. Right? But for the bottom, I won't do the same. And this is the reason. If I turn back the PCB on, you will notice something. Let me tilt a little so we can see what I'm talking about. Or even finish up the sketch, yeah, so that we can have a good view. Just take a good look at what's happening there. This is the line I was talking about. I don't want to pull it by wall thickness as other ones do. Look at where the port stops, right? Can you see where this port stops? Let me do this other view. This is where the port stops, and this is where the board is. Now, what we are trying to do, after creating this wall, we'll do a projection. So you cannot allow the base to exceed this PCB. So the highest thing we can do is to say, okay, let it lie on the same line as the PCB. When we are extruding, you will have a clarity of this exact thing I've said, but just have it in mind. The reason why I have to, go about it that route. So I'll turn off the PCB, right? And just use, go back to the sketch mode, edit the sketch. And use what? Another constraint now, very useful, collinear. That is, we are all going to be on the same line. That's how I always like to, explain that. Can you see? It works very fine. Same thing you're going to do with this other aspect. Drop, collinear, right? Since we have, if you notice, this one now is fully defined, right? I will close up this point. You see why we are doing all of this? My time is, okay. But let's just get this one out so that maybe we could round up. Right? Line, pick it up. Okay. No problem. Just come over. You can see use a constraint to correct this as well. Say vertical or parallel rather. Yeah, correct. Okay, so this is what we have been able to get, right? So for these other aspects, we do the same thing, but this time around we just do relationships. So you could just say, let this height and this height, after they are the same, be on the same level. So collinear, click on collinear, click on this point, click on this point, right? That one has settled. The next one is this wall. So this one will require a dimensional constraint now to actually tell the magnitude. So I'll say, okay, click it up. This one me adding shell. Look at what I'm going to do. I just come over to this existing dimension and click. So automatically I have tied this guy to this guy. So once you do an update, they will all update. So same thing here, pull up, same thing, click. Instead of me putting 5, right? I'm clicking on an existing dimension, right? So now we've been able to settle this as well without going all through the headache we did here. So having done that, this is what we are trying to achieve at the end of the day. Okay, one more thing, sorry. Let's click, edit. Same thing, you have to close up this part. Same one too, same thing. Okay, doesn't look straight. You could use your constraint to arrange that as well. Particle constraint. Okay, so we'll do finish sketch. Now, when you turn back on your main design, which is the enclosure, right? The first thing we'll do is to open up the hole first before building the guide. So what I mean by that, I'm almost done. You just click on extrude, select this, sorry, wrong selection. Select this inner part, select this inner part. Now on the magnitude, that's the extent of the extrude. I will use a parameter for this, right? So first of all, we change the operation to cut. So I don't want it to give me a new body. I rather want it to cut out a hole. So that's what I mean by the operation cut. So now go to extent. Is on distance. Now, what I will do to keep this in uniformity, like even if somebody comes and say, change the wall of the enclosure from, we are using 2 mm now, and someone say, I want it to be 2.4. Now, by tying this cut as the hole we are about to drill now, with that, wall thickness will mean whatever the wall thickness is, it will also what update accordingly, right? I'll show you 2 ways when we are doing the second one. I'll also show you what how it works. So we just come here and say shell. Remember, shell was the thickness of our wall. Direction, okay, reverse direction. I have to pull this other way, right? So extend, that means I will say minus shell. Remember our sign conversion, right? Okay, so you can see what's happening there. And you see what's happening there? It's drilling the hole with the magnitude of what the shell is. But I have to zoom in and see that this is giving me exactly what I want. Okay, that works. Now there are cases where, because of this round, you notice there's a round transition here before you have this square. So there are cases where the one what we've just seen might not work for you. So you just come over to do your edit. You change the distance to the one we used earlier on. Do you remember? We've used distance, we've used objects, but we've not used all. So you just change the distance to all. But you also have to be careful when using this, because what it means is that it's going to drill the hole from here down to, like, it just keeps going. You understand? Anything on this part is going to also drill a hole on that part. So it means that if there's another object in this side, it will drill from here and also enter that object. So that's where you have to be careful on, some of those commands. But the distance works very fine. So we just click on it. Just had to show us. Now we still go back to that same sketch. The sketch we just finished using. This one now. This is it. Sketch 4. So what do I call it? Naming convention, which I pointed out. Call this what? Port. Priority. Right? So I will turn port to be visible because I still have interest in port, right? So pick up my extrude command, pick this up, pick this, and this up, right? And then pull out. It's still trying to do a cut, but this time around, we don't want a cut, we want a join. So operation, join. It's as easy as that. Are we good? So lastly, the extent of this a wall coming out, this is where FDM rule comes in. Because you don't want to just pull this out. Yeah, it could be nice, it should be longer or shorter. But when you're going to print this out, that's when you will know if you did the right thing or not. So we're going to keep this. Okay. To 2 mm. And then first of all, turn on the PCB to see that we are on track, first of all. Okay. All right, so I'll turn it back off. I wanted to confirm that we are doing the right thing. And you have that. You can turn off the sketch. This is what you have so far. Good. On the outside, it's just a normal cutout, but on the inside, it's guiding the stuff you're bringing in. Now, why did I select 2? FDM rule, we're going to see it tomorrow. So I will even look at it here. I actually created it. We created it together just before this time, called FDM Edge. So we'll even we'll just edit that guy we just created. That means we're almost done. So right click, edit, future. Instead of using to call it what? Say FDMH. That's the extent of it. You pull back your PCB on. Sorry, I have done a misplacement. Just a moment, please. Drag it off. Okay. All right. Right click and edit. So we'll call this FDMH. Okay. So guys, this is where we are going to stop for today, but now you could just examine to see what we have been able to do so far. I wish we had more time. So if you just click on the final assembly now to activate, so everything comes up. This is how it looks like. You have the part where you want to place your screw. You also have a part where you've guided your port, right? So you don't also want easy access. So if you're looking at it from this end, this is what it looks like, right? For you to do what you want to do, to have that interfacing. And so we probably, if you're sent the file today, you might probably want to continue. That's adding this other two. You just saw what I did here. It's exactly the same thing you do here. All the processes I repeated, like on this, try to get this, is what you repeat here and here to get this about. If you can't, that's fine. We'll still get it done tomorrow. And I think I will stop here. So thank you so much for your time. Over to you, Tolu. I don't know if there's any question anyway.
Let me get feedback. Yeah.
Right. So most likely we are going to have those questions answered. Just a few answered today, and the remaining will be answered tomorrow. But then, thank you very much, Mr. Fonime. While Mr. Adoki is gathering the questions, I just want to appreciate the process. I know that Fusion 360, you need to follow and pay attention. So I know this is just an experience for you to gain a hands-on knowledge, and after now you just have to go back to your software and give yourself the training by practicing all that you've seen on your own. So if there's still any challenge that you have, you can still come again tomorrow, then it will be properly addressed. All right, Mr. Edoki, is there any question?
Yeah, there's no question for now. Maybe after we practiced with the recording, then we'll have questions by tomorrow, sir.
All right, if that